Hello once again. This is the Business of Open Source track, and it's my pleasure to introduce David Bitner from Development Seed.
Thank you, and I'm lucky to have the talk that is right before everybody's going to be streaming in, grabbing lunch. So hopefully we can get through this without too much clattering going on. I'm going to talk to you about a project of ours, TiPG, which is an OGC features service that allows you to serve, or an OGC API service, which allows you to serve OGC features and OGC tiles directly from Postgres and PostGIS database. And where's the clicker? So OGC API is basically the next version of WFS for those of us who've been around for a while. But rather than all the ugliness and XML and everything involved with WFS, we can use vector tiles for the tiles display and GeoJSON and JSON sort of for all of our interaction. TiPG supports all of OGC features, part one, sort of the core features. We do not support CRS by reference, so everything that you're getting out of TiPG is in geographic coordinates, 4326. We do allow have full filtering using CQL2, the Common Query Language specification, which is very SQL-like or SQL-like, and OGC tiles specification, which allows us to have XYZ vector tiles. The core and the heart of TiPG is really just leveraging the power of Postgres and PostGIS. And we want to make it so that you have your data in Postgres and PostGIS, and you just want to make it available in services. TiPG tries to allow you to do that without having to do anything else. There's no config, you don't need to configure your layers or anything. The point of TiPG is just the data, you have your data in the database already, you want to display it. In doing this, imitation is the sincerest form of flattery. I don't know if Martin or Paul are in here from Crunchy, but really, what TiPG does is very similar to something that they had done with PG Feature Serve and PG Tile Serve, and before them in Rust there's an implementation called Martin. But there's not that much duplication because all of the real core hard stuff has already been done in PostGIS. So there's different wrappers with some of these different projects that allow the use for kind of different scenarios. And for us at Development Seed, that big scenario was really, we work with FastAPI and we do a lot of Python projects where we're creating services that we want to plug in different components. So TiPG is built in Python and is really leveraging the FastAPI framework. And the FastAPI framework really allows there's many tools that are built off of it, so when we're building services, we don't have to worry about a lot of that service stuff. We also try not to reinvent the wheel too much, and we use a lot of standard libraries. So Pydantic, which allows us to do a lot of sort of input validation. PyGeoFilter, we didn't want to have our own implementations to deal with the parsing the query language, PyProj for mercantile, Jinja2 for templates, Async PG for database connections. Really we're standing on the shoulders of all of these other projects. One of the great things about FastAPI, and one of the big use cases that we had for creating TiPG rather than using one of these existing libraries, is we want to be able to plug these feature services in and have a much larger set of services that incorporate both the feature services but numerous other custom APIs for our customers or various other things. Using FastAPI also allows us to, we don't need to worry about building tools for authentication and security. We don't need to build something that's going to create open API documentation for TiPG or validation, and we can use the things that already exist with FastAPI. There are many libraries, that do authentication, which you can plug in. We don't do that for you because there's already things that you can grab and assemble together. FastAPI also has numerous middleware, so if you want different kinds of compression or inject timing into your requests, well, we don't have to do that as part of TiPG because you can already do that when you're assembling things with FastAPI. We started putting a lot of things together, very common. So it was very common for us to want to have a service, T-Tyler service for displaying more raster data, and Stack FastAPI for catalogs. And we kept doing sort of the same pattern over and over again. And so one thing that we've done recently at Development Seed is we've now built, TiPG is an individual component that you can use separately, but we've also created EAPI, which is a kind of an opinionated gathering of numerous other components that we've worked on. So PG Stack, T-Tyler, as well as the plugin for T-Tyler that lets you hit PG Stack directly, TiPG and Stack FastAPI. And EAPI bundles that all together. If you want to learn more about EAPI, there's a talk at 4:30 that is much more about that overall kind of bundling of all these different tools to make that whole thing much easier so you don't have to go out and kind of put all these things together. It's already done for you. But if you're using TiPG, if you just have a database and you just want services out of it, it's as easy as pip install TiPG, and Uvicorn, which is just a WSGI service. And then you can either use, or you could use our Docker image that comes with TiPG, and you just need to give it the database credentials and fire it up. And all of your spatial tables that you have in the database are all of a sudden you're going to have a lovely service to be able to look at them. And this is what you end up getting. So in addition to providing the GeoJSON output that you normally get from OGC features, there's also templating that you can create templates, which there are kind of the default templates that give you this view that are pretty plain, but they're Jinja 2 templates. So if you're used to templating, you can go in and customize and have a user interface around your features API, as well as the actual vector tiles and feature services, getting that GeoJSON endpoint. Every endpoint in TiPG, in addition to having a data endpoint, so JSON or GeoJSON and vector tiles, also has an HTML endpoint that you get a nice view. So you can actually just give your database credentials and boom, all of your data. You've got a nice little user interface around it, as well as the actual data services. Nice thing that FastAPI gives you is you also have kind of your API documentation that you can click through. You can see, what things are available at each endpoint, and your open API documentation will just kind of give you all of that documentation about your data and about how to use it. The way it works in OGC Features API is you have collections. Think of the collections as maps to your Postgres tables. And then within each collection, you have your items, which are the individual records within the collections. There is some sample data set. If you fire up the Docker image, it has some country borders. It has, some Landsat tile samples. But you get your list of collections. You can go to the collections endpoint. You can get a nice little table that displays that. You can also get that data as a JSON layout. So if you're trying to incorporate into other things, you've got that automatically. When you go into each collection, you get your links and metadata about that data set from what we can extract from the table structure in Postgres. And you also get a handy little viewer that just has a leaflet map that now you can see the countries that were in your table. And what you're actually seeing display here is the vector tile service itself. And so the nice thing is you can get this just basic preview, so you can go explore your data and be able to see it immediately. And just showing in the developer tools to show that what we are seeing here, the blue line that we're seeing in the map, is just a vector tile call, an XYZ call that's getting the vector tiles to display that data. And we didn't have to do any configuration. We just had this data sitting in the database, and now we can view it. And we can also get a tabular display on our viewer that we can page through. And behind the scenes, that's just grabbing the GeoJSON page by page. So we support paging through that data to display your records. And you can see, so we're paging through the data, so we only have 10 records displaying in our little table, and we're only seeing that same subset that matches the paging on the map itself. And in this instance, those features are showing up coming from GeoJSON, not from the vector tiles. And so this is what if you just go to the GeoJSON endpoint, you're getting your, all you have to do is change the format to GeoJSON in your URL, and it's that same base pattern of base URL, and now you're just getting your GeoJSON output. One of the cool things that we also do is, in addition to exposing any tables or views that you have in your Postgres database, any set returning function, we also allow you to expose. And so you can create procedural functions within Postgres that, as long as they have any output that is a set of data, so returning more than one row, that will display, allow you display as an OGC feature service, as a tile service. And if that set returning function returns a geometry, if it doesn't return a geometry, you can still get the tabular data. You can still get the HTML table of the records. And if it has a geometry, it will return as the GeoJSON and as the vector tiles as well. And so just the way that it works, because it's any set returning function, and any set returning function that returns geometry for showing on a map, even the standard ST square grid that is part of PostGIS will show up in your catalog. And so the square grid function just takes a geometry that are the bounds of the data, and it takes what is your size of the grid cell. And so this is in geographic coordinates. So what we're showing here, if you can see in the URL, which I'm not so sure kind of how the resolution on these monitors is, but all we're passing is a grid size equals 3, bounds equals, and then we're in the URL, we're just passing a WK geometry. And it will take those parameters. They have to be your functions need to have named parameters because we need to map that name to the variables. If you're only using positional parameters in your procedural function, it will not display. But now we are dynamically creating this ST square grid. That's not a table, that's not a view in the database. That's a function that is creating that in real time as you're pulling it up. And go for it. So this is just showing, now we have the collection items, we have our countries where this is coming in as GeoJSON. And one of the questions is, why do you have the difference between being able to use the data as tiles and be able to use the data as GeoJSON? If you're just making a map and displaying, you really want those tiles because it's going to be much more performant, it's going to be much faster. You're only downloading the data that you're using at that time because the vector tiles are generalized, for that display. But this is also, hey, I want to use this data, I want to do something with it, I want to run an analysis in QGIS. You can connect QGIS to the OGC Features API or anything else, and you actually want to use that data. For using the data, you want GeoJSON. We still, you can display GeoJSON on a map, but something like the Canadian border is going to be pretty dang huge if you were trying to do that, and so definitely not ideal. Filtering. You can filter the data, and so a lot of times you don't just want to see all of the data that you have in the table. You want to filter it, and so you can use basic filters that, for equality's sake, where it's just the column name equals the value that you want to filter. So in that last example, we had country name equals Canada, and we were able to filter that data. In this instance, we are using a CQL query that is much more complex. And the CQL queries, you can have and ors and parentheses, spatial predicates, where you're passing in your geometries in GeoJSON that you can do whatever kind of filters, build up compound filters that you're combining with other things. So in this case, we're just using an OR filter where we're saying where the population is greater than, there's no commas in there, but greater than, like if someplace that has a really big population or the area is greater than 100, in this instance, it's just 100 square degrees because that, the unit of the data. And so you can see we've got, the US, Canada, Brazil, but we're not showing, a number of the smaller countries. But the CQL2 really allows you to make your queries kind of as arbitrarily complex as you want. And that filter then applies both to any features that you're getting returned as GeoJSON, but also as the vector tiles. So it really allows you to be very dynamic in what you're pulling back. And that's kind of what we have with this talk. As I said, if you want to learn more about sort of that EAPI and how you can then integrate the feature services and the vector tile services, along with much more having a big, metadata platform to track all of that thing and different other services, definitely come see Sean Harkins at 4:30. I'm not sure which room that's in, but later today. And thank you all.